Good morning, you amazing fourth graders. Happy Wednesday. Hopefully you all have your wacky hair or wigs on. I don't have mine on yet, but I will, and I'll post a picture. Yesterday you guys had to, on Tuesday, you had to continue to work with angles, and you were working on pages 342 to 343, and I thought that I would go over those pages with you just to make sure that you're on the right track. So number 2 said there are blank 1-degree angles in a full circle. And Mrs. Davis described this on Monday to you guys in her video. A full circle has 360 degrees, so there are 360 1-degree angles. So your answer here for number 2 should have been 360. Ooh, let's see if I can do this. It's not going to be perfect, but it works. And then so an angle showing a full turn through a circle measures also 360 degrees. So you should have 360 for both number 2 and number 3. Then we're supposed to use this drawing right here to answer question or problems 4 and 5. It says the drawing below shows an angle that turns through several 1-degree angles. Use the drawing to answer problems 4 and 5. So if you look at this drawing, I see 1, 2, 3, 4, 5, 6, 7 1-degree angles. And so it says right here, the angle shows a turn through 7, and then you're going to say 1 degree angles. So if there's 7 1-degree angles, 7 times 1 is 7. So the angle measures 7 degrees. Okay, I'm going to pause this really quick so I can erase it, and then we can move on. Okay, sorry about that. I wanted to erase so that we could move on. So problem number 6 says, an angle shows a turn through 19 1-degree angles. What is the measure of the angle? Well, if it's 19 1-degree angles, 19 times 1 is 19 degrees. So we'd have 19, and then if you want to spell out degrees, I'm going to stop at DEG. Okay, and then number 7 says an angle measures 275 degrees. How many 1-degree angles does the angle show a turn through? Again, now we're working backwards. So now we have 275 degrees, but how many 1-degree angles is that? That's 275. So hopefully this was easy for you guys to understand and to work with. And so hopefully you're getting these answers right and you're not having any problem as I'm going through this. Now, question number 8, I felt like it was kind of, the wording was a little confusing. It says, why is it reasonable to use the same units to describe circles and measures of angles? Okay, well, again, when we're talking about, I'm going to go back to what Mrs. Davis talked about on Monday. So when you're looking at this circle right here, remember that an angle, if these pencils are our angle, one pencil is one ray and the other pencil is the other ray. So an angle is made up of 2 rays. So if you start at 0 degrees, if you start an angle at 0 degrees and you turn one of these rays all the way around, you're going to go 360 degrees until it reaches the other ray. So when we go back to our question, it says, why is it reasonable to use the same units to describe circles and measures of angles? Well, if you start an angle at 0 and turn one of the rays of your angles all the way around until it reaches the other ray again, it will form a full circle, just like we described up here. Okay, if we take one of these rays and move it all the way around until we reach the other ray, we make a full circle. So you can start the angle at 0 and turn it all the way around to meet the ray again, and you have a full circle. So I hope that that makes sense to you guys. If not, please reach out to Mrs. Davis and I on Google Classroom, and we will be more than happy to help you and explain it a little bit more. Okay, so it says that Mary lays a notebook flat on a table and opens it as shown at the right. How many 1-degree angles did Mary turn the front cover through? So if you take this and you turn it here, this angle right here that it's showing, that forms 180 degrees because it forms a straight angle. So for this problem right here, you would write 180 degrees. Okay. So then it says, think about the angle formed by the bottom edges of the front and back covers of the notebook. What does the angle look like? It looks like a straight angle or a straight line. Sorry guys, I'm not the best with making my words. So, but hopefully you guys are laughing and getting a good little chuckle today. So you can say straight line or straight angle for this problem right here. Okay, then number 10, a second hand takes 60 equal turns to make a full circle around a clock face. How could you find the number of degrees the second hand turns through in one turn? Okay, so think about it. You're taking a circle and you're making 60 equal turns. Okay, so a full circle is 360 degrees. So 360 degrees, and if you divide it by 60, then you will get 6 degrees. Okay, sorry about that. My son needed me for a second. All right, back to the last few problems. I really wanted to go over this problem because you're going to have a problem that looks similar to this on your quiz. So I wanted to go over this with you. So number 11, 12, 13, and 14 are all based off of this circle right here. I know it says to work with your group, but obviously you can't do that right now. So you're going to work on your own and then we're going to go over it. So it says between fractions of a circle and angle measures. All 3 sections of the circle are the same size. So if you see this angle measure, this is 1 angle measure, this is 2, and then this is your 3rd one right here. All of these angle measures are the same size. And we know from working with fractions that when we divide a circle into 3 parts, the angle shows a turn through we have 1, 2, 3 parts. So this number right here should be a 3. Then the angle shows a turn through 1/3 of 360 degrees. Okay, we went from this problem, which says the angle shows a turn through 1/3 of a circle. We know that a circle is 360 degrees. The angle shows a turn through 1/3 times 360. Okay, so that's 1/3 of 360 or 1/3 times 360. So when you think about that, that's like 360 divided by 3, just like we did up here for this problem where we did 360 divided by 60. Well, if you think of 3 of these, if we have 300, then we know that each one of these has to at least be 100. Like if we're thinking about it and if we're dividing the 360, we know that each one has to at least have 1 in it, 100, 200, 300. So now we have 300. So if we have 360 and we did 300 for your division, then we have 60 left. And we have 3 boxes. So we could do 20, 40, 60. So your answer would be 120 degrees. Okay, so the angle measures 120 degrees. You can always check that by adding 120 plus 120 plus 120, and you'll get the 360. So this would be minus 60 right here. Sorry, I know my writing with this tool is not the best. But this is what we do with division. We break it down. So each section would need to be at least 100, because 100, 200, 300. So that would take away 300 of this 360. And then we'd have 20, 40, 60 left. So it's 120. All right. Well, I hope that that helped to explain pages 342 and 343. I hope you are having fun doing your Google Slides and finding angles around your house or online. I cannot wait to see all the Google Slides that you guys turn in and all of the creative angles that you find. So have a great day and continue doing a great job on your e-learning. Talk to you soon, guys. Miss you all.